Hi and Assalamualaikum. My name is Nur Ashila and I will be presenting the introduction part. Durian is a fruit that is originated from the Borneo Island. It is very famous as the king of fruit and well known with its exotic smell and remarkable taste. Over time, durian has been a new impact in the food industry, especially as a new flavor in food such as in cakes and ice cream. However, durian can only be harvested in its own season, which is usually starting from June to August. Since the demand for durian is high, various modifications of handling and processing durians has been done to maintain its quality and flavor. One of the best methods in maintaining the freshness of the durian flesh is by separating the flesh from the seed. Based on our datum from MSD, they had invented a cutting machine with a 15 cm of drill head and several blades which will penetrate and open the durian. So the improvisation of this method will be discussed in this project.
The objective of this project is to design an automatic system for durian's opener. The system is required to operate with minimal manpower supervision. This project is also to improve the current semi-autonomous system of opening durian in the food industry. The second objective of this project is to increase the production rate and the cycle time. The system is acquired to achieve production rate of 600 durian per day to be processed.
Problem statement is high demand but low supply. The demand for durian had increased drastically. However, the exporter do not manage to meet this high demand due to low supply, leading to low production rate. That the process are manually done, which lead to high cycle time and low production rate. Currently, there are no proper method to replace the conventional method. Thus, the worker need to do their work manually.
Now, let us have a look at the scope of project. Firstly is the type of production. This machine is being designed to open only one type of fruit, which is durian. Thus, the working mechanism might not be suitable to be used for opening other fruits. Secondly, the scope of this project is for industrial uses. This machine is targeted to be used in industrial uses for large production of opening durian. The aim is to ease the opening of durian automatically instead of manually. The third one is the production rate. The machine is designed to produce the fleshing yield around 30 to 40 kg per hour. And finally, the operating mode of this machine is the fully automated machine with minimal manpower.
Okay, now I will going to explain about overall operating system. Our system consists of 7 main components, which are loading bay, conveyor belt, pneumatic cylinder, fixture, disposal tank, durian cutter, and robot arm. How the system will be operated? Durian will be placed in the loading bay and will pass through the gate one by one. Durian will be transported to the cutting section using conveyor belt. At the end of the conveyor section, there will be a gate to ensure that the durian tilt to the vertical direction. As the durian reach at the end of the conveyor belt, pneumatic cylinder will operate to push the durian to the cutting section. Simultaneously, the fixture will move downwards. As the durian reach at the position, the fixture will move upwards to hold durian as to ensure it is in right position during cutting. Then the durian cutter will cut the durian and the robot arm will collect all the durian flesh. Pneumatic cylinder is then will push the durian husk into the disposal tank.
Fixture design is one of the components in the system. Its function is to hold the durian so that it is in position in vertical order right before the cutting operation. The design reference is square-shoot mechanism. Square-shoot mechanism is the best combination of cam, slider, and crank. This mechanism is mainly to change from rotational to linear motion. The height of the slider is controlled by the angle of rotation. Angle of rotation will be 180 degrees for a moment to stagnate the movement of the slider. This is for a fixture to hold a fruit right before the cutting. This mechanism is powered by DC motor. In the system, each design will be assembled in 2 pairs for 4 fixtures to hold the fruit.
Now we will continue with the conveyor belt. This is the detailed drawing of the conveyor belt. The total length of the conveyor belt is 420 cm and the width is 60 cm. The conveyor belt is the part where it will transport the durian from the first point to the cutting point. It will guide the durian to move in one direction. With the gate that has been designed, it will make the process easier. Then, this is the exploded drawing. There are 9 components inside excluding nuts and bolts. There are conveyor frame, conveyor barrier, the belt itself, the pulley that holds the belt, the shaft that guides the pulley, the conveyor stand, the holder of the slider itself, and lastly, the motor that is needed to move the belt.
I will explain about cutter mechanism. Cutter is being used to cut the durian. So this is the technical drawing for a cutter mechanism, and this is the exploded view for the cutting mechanism. So this cutting mechanism consists of blade, ring, major rod, cutter base, piston, minor rod, bolt and nut, and also piston rod. So this is how the durian cutter works. This is the simple animation to show how the cutter moves to cut the durians. The cutter will move downwards and the piston will stay in its position. As the piston already at the maximum, it will restrict the movement of the ring. The ring will stay at the same position while the cutter will still move downwards. This will cause the minor rod to trigger the major rod to be opened up to 60 degrees. The major rod will be used to push the durian husk to be opened.
Hi, now I will be explaining on the detailed drawing of pneumatic claw and vacuum gripper. There are 2 types of pneumatic claw in this project. The first pneumatic claw is used to grip durian to ensure it is in a vertical position before cutting process. The second pneumatic claw is used to push durian husk towards disposal container at the end of operation. This is simple simulation for the pneumatic claw. Both claws use same principle. It will drive by an air compressor to give force to the pneumatic arm to push an object towards the desired location. This is the detailed drawing of pneumatic claw. The pneumatic claw consists of pneumatic gripper. This gripper is designed according to the diameter of the durian. It will also consist of pneumatic rod. The rod is designed according to the reach of an object. Next is the exploded drawing of pneumatic claw. The pneumatic claw consists of many components, include screw, pneumatic rod, pneumatic gripper, the stopper, and also the rod holder. Next, moving on to the robot arm. Robot arm are used in this project to separate durian fruit from its husk using plastic gripper and vacuum suction. This robot arm consists of color sensor where it will detect the durian fruit color and separate it from its husk. This is the exploded drawing of robotic gripper. Robotic gripper consists of robot arm, controller, and gripper. The gripper are made out of plastic and are highly used in the food industry to grip food. This video are provided by the Fiat company to show the industrial use of robotic arm with the plastic gripper in the food industries.
For operational expenditure OPEX, the components covered are maintenance costs, labor costs, utility costs, raw material costs, transportation costs, and building rental. These are the continuous costs that must be borne by the system to operate.
Maintenance costs. These are the list of equipment that need to be maintained throughout the operation. The maintenance cost is calculated yearly. They are based on current prices from catalogs, online hardware shops, and others. Labor costs. The system needs 3 manpower for every station to ensure the system is running smoothly. Admin worker. 1 person is needed to manage administration tasks. Maintenance worker. 2 workers are on standby if any maintenance work needs to be done immediately. Utilities costs. 2 main utility services are considered in operational costs. The amount of power used is the accumulation of power needed to operate all equipment in the system. Raw material costs. Every durian is considered 1.5 kg each. Allocated price for 1 durian is RM7.50. Raw material cost is calculated after multiplying the price of each durian with operation time. Transportation costs. The services provided are loading and unloading of the fruits and lorry rental. The transportation is scheduled to send the fruits once every week.
And lastly, building rental. The whole factory plant is rented for RM1,200 per month.
So, let's move on to the capital cost of this project. The capital costs include setup cost, equipment and machinery cost, and lastly, renovation cost. The setup costs include the installation price of each equipment. The installation price is 15% of the equipment price. Overall installation price is RM28,696 for all equipment in this project. The equipment and machinery costs include all the total price of equipment and machine used in this project. The renovation cost is the renovation price of the factory, which costs RM5,000, and the total capex of this project is RM228,678.
Now, we will continue with projected profit. The expected number of durian that we will use is 600 durians per day, and packs of durian flesh obtained are 390 packs per day. For each pack of the durian flesh will be set to 500 grams, and the cost of each will be 40 ringgit. Hence, the annual profit will be 390 packs per day multiplied by 40 ringgit, and the total will times with 240 working days. The total of annual profit will be 3,744,000. Next is the project management. On the right side is the cash flow table, and the left side is the cash flow diagram for 5 years. For the 0 year, there are no revenue and only expenses, as it is the startup year. Revenue start on the first year and expenses will be 1,716,751 ringgit. For the year of 2, 3, and 4, there will be additional expenses, as it is the maintenance cost of the machines. Next is the net cash flow. For 0 year, there will be negative, as it is only expenses happen. And continue with year 1, net cash flow will be 2,027,249 ringgit. As we can see, year 1 and year 5 has the highest, as there are no maintenance costs in the respective years. For the payback period, the cash inflows are uneven, hence we need to find the payback period. It is by calculating the cumulative net cash flow and uses the formula stated. Payback period equals to A plus B over C, where A is the last period number with negative cumulative cash flow, which will be at year 0, and B is the absolute value of cumulative net cash flow at the end of period A, which is negative 228,678 ringgit. C is the total cash inflow during the period following period A, which is year 1, that is 2,027,249 ringgit. So the payback period will be 1.2 months.
Project activities and network analysis could help to estimate the exact time for the entire project to be completed. It will also help to foresee the current progress of the project. In here, the relationship among the activities is developed to decide which activities is the immediate predecessor to the others and the time taken for each of them. With that, the network connection between all the activities are developed by using the AOA network convention.
Critical path analysis is used to determine the length of time an activity be delayed without delaying the entire project. In order to perform critical path analysis, the AON network will develop. Slack time will be calculated to identify either the path is at critical or not. For our project, we found that the critical path is from A, B, F, J, and lastly K.
In conclusion, an efficient and optimum production of Durian flesh with minimum cycle time can be achieved with fully automated Durian opener. Objectives of this project has been reached, which is to design an automatic system for Durian opener and also to increase the production rate and cycle time of the process. The semi-manual Durian flour process has recorded of a cycle time for 0.4 Durian per minute only for cutting process, while upon calculation of cycle time with 3 line of machines will produce cycle time of 0.5 Durians per minute for the whole complete process. With this cycle time, the design of automatic Durian opener can achieve to process 600 Durians per day.
For recommendation, these 3 elements, which are economy, social and ecology, will be discussed in sustainability of the design. In economy element, introducing the design to local market and not limited to giant company in food industry. This is to achieve all level of production chain in food industry. And number 2, better technology can be applied in autonomous system. The system can be improved in terms of robotics application and technical knowledge. For ecology aspect, to reduce power usage for every component in the system. Use low power consumption to preserve energy efficiency. And number 2, proper waste disposal to reduce pollution. Poor handling of waste can lead to environment contamination in the long run. And lastly, for social sustainability, to improve knowledge on technology development and equipment handling. Knowledge is an important element to bring humanization towards progressive community. And number 2, locals will be exposed to global market and incorporate with different society. Different point of view and opinions can be shared between the locals and other people.